So this is exercise which is related to alternative to practical questions, and topic-wise questions are divided here in this exercise. The first few pages you can see the tables information which you should know about before doing this whole ATP. The last we did was topic one question electrochemistry and chemical energetics, as we did one question from each. So this we completed in the last session. During the session, you can use your mic or a chat to participate. So today we'll do chemical reaction, question 1.
Sir, what page?
Page number, this is page number 28. Page 28. The topic is the chemical reactions. The first was electrochemistry, second is chemical energetics, and this one third is chemical reactions. So we'll do question 1. As I mentioned, like I will do first one question from each topic and then we repeat this cycle. And later you will complete this exercise by yourself. I will share the answer key with you. So a student investigated the rate of a reaction between a small lumps of calcium carbonate and the dilute hydrochloric acid. This is page 28. The experiment was done at 2 different temperatures. So we used 2 different temperatures using the apparatus shown in the diagram. All other conditions are kept same. And after the session, once you're we finish, you have to send the picture, the image of the questions we discussed today. The experiment 1, we used 25 cm cube of a measuring cylinder. So 25 cm cube of a measuring cylinder, 50 cm cube measuring cylinder, 25 cm cube hydrochloric acid is poured into a boiling tube. So the maximum capacity of 50 cm cube, and it was filled with only 25 cm cube of hydrochloric acid. It's like a half was filled with a hydrochloric acid. Then it was poured into a boiling tube. So we poured into a boiling tube. The temperature of a different temperature of dilute hydrochloric acid was measured using a thermometer. 10 grams of a lump of calcium carbonate were added in a boiling tube. The bung was placed and the stopwatch is started. The volume of the gas in the gas syringe was measured every 50 seconds for 250. Like after every 50 seconds, we record what is the volume of a gas given off, and we did this for 250 seconds. Then in experiment 2, we used the same measuring cylinder and 25 cm cube of hydrochloric acid. But this time the dilute hydrochloric acid in the boiling tube was warmed. So before initially it was not, but now we warm by increase the temperature. Temperature of a hydrochloric acid was measured using a thermometer. 10 grams of calcium carbonate, again it is there, and the bung was placed and stop was started. The volume of the gas collected and the gas syringe was measured for every 50 seconds for 250 seconds. In the question, you have to use the diagram to state the temperature. Like first, use the diagram, complete the temperature. What is the temperature here? So it's 23. We don't have to write the unit. Why we don't have to write the unit? Unit is already written there. So we don't have to write the unit. The next part, we have to measure the volume of the gas. Just a minute, I will arrange the screen and then you will use screen annotation to complete the volume of the gas. The first one is 0. Then 12. Yes, that's right. The first one was 0. That's correct. Then 12 was there. Then 20. Then 27, 32, and 36. So these are the volumes which we record. Volume of a gas we recorded. The next one, first complete the temperature reading. What's the temperature reading for experiment 2? So that's 44. Then use screen annotation. I will just arrange the screen and use screen annotation to complete the volume of the gas which was collected in the second experiment. The first one was 0. The second one, 25. The third one, 35, 40, 40, and 40. So why the volume is not changing here? What is the reason for that? What might be a reason why the volume does not change?
Because the reaction finished.
So reaction finish or the limiting
one of the
reagent?
reactant is used up.
Yeah, good. So one of the reactant used up, reaction finish, reaction stop, or limiting reagent used up. That's the reason for that. The next part we have to plot a graph. So and plot the result of experiment 1 and 2 on the grid. So I have to just I will write the values first because the volume of the gas collected and the time. So for experiment 1 and experiment 2, I will write simultaneous. And then we'll plot a graph, experiment 1 and experiment 2. Normally for chemistry graphs, the grid is already marked. Like most of the time, the axis is already labeled, so you don't have to label the axis. So first it is 0 when time is 0. Then it is 12 and 25 was there. It was 20 and 35. And it was 27 and 40. And then 32 and 40. And then 36 and 40. And the time 0, 50, 100, 150, 200, 250. Like the time interval was. When you plot a graph, use a pencil to mark the points, then even the curve also or a straight line, use a pencil. Once you're sure that nothing change should be done, then you can just rewrite or just overwrite on the pencil by using a pen. But not in the beginning. You always, whenever you're doing a graph or plotting a graph, use pencil. So example, the first one, it is 0, 0. So this is the first point. Then it is 12, the volume collected on y-axis. Each box is representing 1. So at 50, it will be 12. So this will be the second point. Then the third point, 20. At 100, it is 20. At 150, it is 27. So 7 boxes above. I'll just zoom in. The points won't change as I marked them initially. Then it was 232. So 230. In case if I miss any point or up or down, just let me know, because on the grid, it may be as I'm using a computer. It's 232. And then 36, 250 and 36. So 250. And this was 32, 33, 4, 5, and 6. So 36. And we have to label your curve. So this is experiment 1, what we plot. Like what we, so this was point 0.1, point 0.2, point 0.3, point 0.4, point 0.5, and point 0.6. And we join them freehand. Should not be horizontal. It's like just continue. Then for experiment 2, we were having, for experiment 2, it was 0, 25, 35. Yes, any question?
Sir, with the ruler or without?
No, it's a curve, so not, it should not be with the scale. Freehand. It's a curve, that's why. You have to use the freehand. So this was 25, 50 and 25. So this will be 21, 2, 3, 4, 5. So 25. And you have to label, like I will mention how to label. 100 is 35. So this was 100. This was 31, 2, 3, 4, 5. I guess this is 35. Then 40, 150 and 40. So 150 and 40. Yes, you can mention a key as well. That's fine. You can mention like if one you're using a cross, another one you're using a dot, you can mention that as a key. So if I use a cross here, but better for because when you're using marking a dots, it's more accurate as compared to just you put a cross. So better label on it instead of marking the points, instead of using a key. Then 200 we have 40. Um, it was 25, 35, then 40, then 40. So it will be 40 again, then it will be 40 again. And when we draw the graph, these are the two graphs. If you put a cross, it's fine. You can just simply put a cross. It's not, you don't have to encircle. Then we have to label them. That's the important part. So on the graph, you can label experiment. This was experiment 1. So you write experiment 1 here. And this one is experiment 2. Encircle the dot. It's fine. It's up to you. If you want to encircle, that's also fine. If you want to even encircle all, it's fine. It does not make difference. Now, these are the two graphs which we plotted. So we have experiment 1 and we have experiment 2. Now the next part, from your graph, deduce the volume of a gas in experiment 2 after 120 seconds. So experiment 2, so after 120, and you have to show this. You can write along the gradient as well. That's fine. It's no difference. So we want to find how much volume of a gas is given off for experiment 2 at 120. So what we will do, we will draw a line from 120 on y x-axis. Each box is represented because 10 boxes equal to 5. So sorry, 10 boxes equals to 50. So each box is 5. So 120 is here. So we'll draw a line from 120 and we find what is the volume. So it is 37 here, which appear up for us. So we'll write as 37. And you have to draw this line on the graph, like keep it. So after 120 seconds, the volume of the gas for experiment 2 was 37 cm3. Explain how the result shows that the reaction in experiment 2 has stopped. How these results can show that the reaction has finished or reaction has stopped. How we can show? Experiment 2.
The line became straight.
So how or the line or there's no change in volume, or it is horizontal line, no change in volume or line level of, these are all the terms you can use, or no change in volume, line levels of, gradient is 0 because when horizontal line or line levels of is the same thing. So as there is no change in volume, it means the gas. Then predict the gas volume of a gas that would be collected in experiment 1. So how much gas will be collected in experiment 1 in 800 after 800 seconds? Basically, after as you can see, it's like experiment 1 is about to end. It's near about to end. And experiment 1 and experiment 2, we have the same amount of the reactant. The only difference was the starting temperature. The temperature was different. So can you say what volume of a gas will connect in experiment 1? For experiment 1 and 2, we use the same amount of reactant. If experiment 2, the total volume was 40, what will the experiment 1? It will be 40. Why 40? Because we use the same amount of reactant and after 800 seconds, the reaction definitely will stop. So we'll get the same amount of a gas which we collected in experiment 2. An explanation for that, what is the explanation or reason for that? Because same amount of a reactant used in both experiment or same amount of the reactant as experiment 2. So, but the answer, the explanation here, you don't have to mention, like the main point is because same amount of the reactant in both experiment.
Sir, can it be because it changed only the rate and not the amount of product?
But this point mentioning same amount of reactant is having a mark. Anything other than this is not relevant. Because if you're not changing the amount of reactant, the amount of product won't change. That's the point you have to mention. A student stated it would be an improvement measuring a volume of a gas every 25 seconds. Explain why this is an improvement. Like what we did, if you read the experiment, we were measuring the volume every 50 seconds for 250 seconds. But now student is saying I will measure after every 25 seconds. But how this will be an advantage or how this will improve the experimental accuracy? You have more reliable and accurate reading. That's good. Because when you have more points, like more data or more points will be there. So you can plot a better graph or you can identify the trend easily. So whenever, because if you are measuring after every 50, so if you are measuring after every 50 seconds, the points were 0, 50, 100, 150, 200, 250. How many points were there? 1, 2, 3, 4, 5, 6. But after every 25 seconds, how many points will be there? It will be about double. No, for average, you cannot mention average here. Average you can only mention when you repeat the same experiment. But you repeat the experiment with the same procedure, then you can take an average. But here what we did the experiment with a different time reading. Like we did for 0, 25, 50, then 75, then 100, 125, 150, 175, 200, 225, 250. So more points will be there And whenever you're plotting a graph, so more data or more points. What is the advantage of more data or more points? It will be reliable, and as we can plot a better graph as more points are there. So better graph can be plotted as we'll have more points, more reliable results are there, and better graph can be plotted as the number of the points increases. If I have only 1, 2, 3 points, I can just make a sketch here. But if I have more points, more number of the points, I can easily work out what will be the actual trend. Is it clear, this one?
Yes, sir, clear.
The next one, they're asking two changes in the apparatus. So whenever a temperature experiment, these type of questions, when they ask two changes in the apparatus, better go to the first page and you can find the answer. So two changes to the apparatus for improving the accuracy. What I should do? If you read the first line in the experiment, we use a measuring cylinder.
So we can use a pipette because
So
it
use a pipette, it will be more reliable. And second thing, whenever, like as you can see, the reaction, we are identifying how the temperature is affecting the rate of this reaction. So we don't want it to lose the heat energy to the surrounding. So what we can do, we can use an insulation. Otherwise, what might happen? Yeah, use water bath is also right here. Like maintaining, supplying the heat energy by using a water bath, like, because what might happen as we have to supply energy from the outside. First, we have to warm the acid, because we are investigating how the temperature of acid can affect the rate of reaction. So first we were having an acid at room temperature. The second experiment, we use the acid at high temperature. So how we can keep the temperature of acid constant here? So what we should do, we can use a water bath. That is one thing. So when you use a water bath, you can maintain that constant temperature, a high temp, say 30 degrees or 44 degrees, you can maintain that. This is one way. Or the other thing, if you warm the acid, then you can provide an insulation or a lagging around this boiling tube. So when we provide a lagging or insulation, so it does not lose heat energy, so the temperature of the acid remain constant. Otherwise, if the temperature change, the rate of the reaction will vary. We want to investigate how the temperature affect the rate. So we want to keep the temperature same. So how we can maintain, either provide insulation, like take a warm acid, provide insulation, or use a water bath and maintain a high temperature or a constant temperature, you can say. So the two changes in the apparatus, use pipette instead of measuring cylinder, as it will be more reliable, like accurate. And the second thing, use water bath to maintain temperature. As we are supplying heat energy from outside, or we want to make it warm or a fixed temperature, water bath. If the reaction is taking place inside and that is releasing energy and we don't want to escape the heat energy to escape, then we will use a polystyrene cup. No, there is no, we don't say 50 cm cube pipette. You will mention pipette can measure an accurate volume of only 25.0 cm cube. So 25.0 cm cube, because first what we were doing, we were using a measuring cylinder or 50 cm cube, which was measuring 25. So instead of using a measuring cylinder of 50 cm cube, we use a pipette of 25 cm cube. Describe how the method used in experiment 2 could be changed so that result can be obtained using a dilute hydrochloric acid at 1 degree. What we should do if we want to obtain this or do this experiment at 1 degree? No, we want to do it at 1 degree. Like we want the acid was warmed to around 44, but we want to do the same experiment, but with a cold acid at 1 degree. What we should do? So we'll use a cold water, or we can use stand tube in an ice bath. If you want to increase the temperature, it's a water bath, or you want to maintain a high temperature. But if you want to maintain a low temperature, then it is ice bath. Ice bath is like, it's the same thing. It's a container which is filled with water and there are ice cubes. So container with water and having ice cube, it's called ice bath. And in a water bath, like a water is there and we are heating a water, and water supply energy to the container or the liquid inside. The melt, basically what we do, we will have a water maybe around 10 at 10 degree, and then we add an ice, so the water temperature start to decrease. When it reaches 1, we will start the experiment. Is it clear, this experiment, this question?
Yes, sir, clear.